Another draft physics video presentation. Two slit stuff mostly, maybe entirely. And so I did see a new lab video. Adam Lark, and it's, the traditional science education kind of video, but this was kind of nice hardware. The gimmick he had for, just rotating and creating different slit patterns. So this is an overlap of the double slit and the single slit. I believe the dimensions would be that there's, I guess a barrier. Well, anyway, there's a slit of this, say, size, and then the double slit is also being performed with exactly the same size openings and the same size impediment. So this distance is the same as this distance is the same as this distance. And so the two patterns end up overlapping in that way. So let's understand. There's no theory for, I don't know what the hell that was, but hell with it. Hopefully it didn't break anything important. So the bottom dotted pattern is the double slit, and the top pattern is the single slit of the same size. So let's just quickly review their theory for whatever light. Obviously, I don't think it's doing this. I think it's doing this. But anyway, goes through a slit, and in the single slit, unlike water just does this. It doesn't do that. In light, and by some miracle, undisclosed physical mechanism, two waves are created, and these two waves interfere with each other. That is, they overlap each other, and that creates this pattern that you see. Now, the wider the slits, the more bars you get, and the closer they are to each other. The closer the slits, the narrower the opening, then you get the pattern you see there, which is a pretty narrow opening, which means you get the longer and fewer bars. So narrower, fewer, more spread, wider opening, more bars, closer together. So those are just basic facts you got to. So anyway, so there's no theory for this, no mechanical theory for why the single slit produces two waves that would intersect. Now, the second problem they have is that when they do create the double slit, with the impediment in the middle, and this distance again is in their math the same distance as what the opening would have been if it was a traditional pattern. So they have no explanation. They say two waves are created. So even though two waves were created in the single slit, there's only one wave created per opening in the double slit experiment. And then you have these overlapping waves, and they give you your, constructive and destructive interference. There's nothing. They have no mechanical explanation for why it's doing this grouping thing, why this is happening. They have no mechanical explanation. Can't tell you why there's this dead spot here. It's not in their math. It's not there. It's just not explained. These two waves can't do this part. Water doesn't do this part. So they have no explanation. So just understand their theory is loose to start. As an explanation. Waves just don't do it. So as much as they claim it has to be a wave and nail in the coffin evidence, it obviously isn't a very good theory because it really doesn't explain the patterns they get, either in the single slit or in the double slit. And so I think their theory needs some work. So anyway, so let's attempt to draw this. Maybe we'll try two colors. What the hell? See if we get anywhere. Alright, because it's going to get a little bit. I just thought of this now, pretty much. So let's draw it this way. So what the double slit represents is surfaces. Okay, so this will be the impediment down here. And let's put the openings over here. All right, so I will draw that as, how to best draw that? Well, let's just draw it as lines. So, you know, just give it a little bit of character that way. And then you have the block in the middle. And then you have another line here. All right. So what I'm arguing is that this pattern is entirely a function of the fact that these surfaces are the active component. They're the thing causing it. So if we use a single impediment instead of the single opening, just to make this drawing clearer, but you will get the same pattern, because it's really just about this distance. Again, in their math, they use the same math to describe an opening. Well, that's a block. An opening. Okay, single opening. So the single slit, they use the same. I guess I should just draw it that way, and there'll be less confusion. So maybe I will. All right, let's take this out and just put it as a single opening, just so we keep it to the proper. Well, it's really no, because this is what I want to illustrate. So hell with that. So I'm taking this block and essentially drawing it down here. I should draw it lower. Sorry, technical issues. Draw it down here. Alright, so this block is really this block. So let's don't count this one for the purpose of this explanation. But anyway, it's the same thing as the slits, right? So if I do two slits at the same size, I get roughly the same pattern from an impediment from a needle as I get from an opening of the same size. So we really know it's about this distance between the surfaces. This is what's dictating the pattern. This distance between this surface and this surface, or this surface and this surface. So this is about surfaces, I think, clearly. All right, so the single slit, the idea is is that there's a certain likelihood of an encounter. So let's just say for the middle pattern, so one thing we do know is that the middle hunk, whatever it is, even in the single slit or in the double slit, you can see that middle section is twice as big. And the logic for that would be, what you can sort of intuit. Let me make it bigger so you get the idea. I mean, obviously this distance thing is the thing that throws everybody off. This is a very long distance compared to the width of the slit. So doing it in these small dimensions does make it look a little awkward. All right, which the thing you can figure out is that if we did take these points as the critical points, okay, the surfaces, and that light's going to move differently from these points. So these are the critical points. Then you could sort of understand that for the single slit, the idea would be is the light can go straight, or it can go to this point here, and obviously this light could go to this point here. And so those, you can see those are in two different directions, right? This one's going this way, and this one's going this way. Now I could have done it this way, and I could have done this one this way, but the idea is it's still the same. They're going in different directions. Now every other bit of the pattern, that is the pattern that goes out here, those pieces of the pattern can only be created by two beams of light that go in the same direction. See that? Same direction. Everything has to be made in the same direction. So that's why the center one is bigger, is because the degrees that it's bending is bending in opposite directions. So it's doubling the size of this first middle section, gets doubled for that reason, because everything else has to be made out of beams that can only go in the same direction. Nothing going in opposite directions can create anything going outward, where the center one is created by a possibility of going in both directions, the opposite directions. So that fixes sort of that. So I've already started pretty much illustrating what you get, how this really functions. So the idea would be is that the narrower you make the slits and the wider you make the slits changes the pattern, in the sense that the narrower it is, the less little clumps you get, and the wider it is, the more you get, but they're closer together. So you make it very wide, it's a very tiny little pattern with a ton of little lines in it. So there's obviously more spread, which I would say you could kind of understand as being when they're closer together, the electrons are under more pressure. Okay, there are fewer of them and under more pressure. And so instead of just bending the light a little bit, because the electron sort of illustrate, the point is the electron is attached to the protons that are in the substance. And there's an external pressure from the universe. But that's really dictated. If there's electrons on this side and electrons on this side, they are communicating with each other. The surfaces know the other surface exists. Dear. That'll be something. So whether they're communicating through the substance or through an atmosphere doesn't really matter. Electrons know where the other electrons are. They always know where each other is, in a sense they feel the pressure. So the smaller I make the impediment, the more pressure the electrons are going to be under, because they're sensing each other and being repelled, and so it's more tension. And there's obviously less ability to be closer to each other, so there's fewer of them. So you could argue the narrower the slit, the fewer electrons. The wider the slit, the more abundant the electrons. And the key is that the more tension it's under, the bigger the diversion. The more it's going to change the angle of the light. So there's a higher probability of a bend. And then the more electrons you hit, obviously the more bending too. But the point is also is that you can leave an electron that was here, or you can hit an electron that was right here. And those two path lengths are obviously going to be different, because these are different distances to a place in space. So, don't think we need this anymore. All right, so there's two components to the experiment. There's this, which I'm going to illustrate, which I'm just going to draw a box here, and then we'll solve that problem. So just understand that. So I'm just taking the four surfaces of the double slit, and I'm just saying let's see these two surfaces, what they're doing, and then we'll see what these two surfaces are doing. And that's sort of what's creating the composite that is the double slit pattern. So because this is a small opening, a small distance, so this is a pretty big distance here. Okay, so these electrons are under less pressure than these electrons, because these electrons are closer to each other, technically. So it could be understood that way. So this is this is the bigger opening, and this is the smaller. And so the idea is you got these two surfaces, and so part of what you have to understand is how much light is getting through. So that's another thing to understand. So obviously, when you have the single slit, the laser beam is in the center of the single slit, and the light goes through, and so you can sort of understand the laser beam is a little brighter in the middle than it would be on the edges, and so you're letting the brightest light through in the single slit, where you're blocking the brightest light in the double slit. So the amount of light getting to the slits themselves is much less than it would be if it was a single slit. So that's another thing to understand. The slit in the middle is getting the strongest light. The slits, when they're separated, are getting weaker light. So the real truth of the double slit pattern is that it's made out of the combination. Without the contribution from these two slits, the photons being bent by these two slits couldn't be seen, because there wouldn't be enough light. All right, so the idea would be is that you just draw your angles like a 1 degree. Say if it's going to be the more it bends more, the tighter the slit. So the idea was, if you said it was 3 degrees, you could just draw that arbitrarily, and you say 3 degrees from this corner and 3 degrees from this corner, and that essentially dictates the light that'll go to this location. And then if it hits 2 electrons, let's say, or if it hits electrons in different locations, like an electron up here versus an electron down here, that would account for the variance in this range. Okay. Now if it hits 2 electrons, you could argue that it's going to be bent twice as much, and so that would be 6 degrees, and so there would be another section of another piece of ring, you want to call it that, if you want to call it that, would be going in this plane, okay, and so it would be filling this void. You could see it as like a ring, so that ring would end up here, and then if it hits 3 electrons, it goes here and here, and so that's another ring. You could see it as a ring. So that's how the light's leaving from the 2 interior surfaces. Then you have the exterior surfaces, these 2, and they're doing the same thing, but they're doing a lot smaller angle of change. So for them, so you can't really draw it straight just because this is really tiny. So in comparison to what you're seeing on the screen, this is a tiny amount of distance. So some corruption in the drawing will be kind of evident because I won't be drawing a straight line, So the 1 degree to change would be a tiny bit from this center. So you'd say, there would be a line from here. So the line leaves here, and I'm kind of drawing it in the image. So when it leaves here, and it's going to get to the wall, which is much further away, so it's going to be magnified, that little angle. And so it would put a spot here. And then this one, say if it did 2 electrons, then that would be 2 degrees, and so there'd be another one there, and then 3 electrons, 3 degrees, and so there'd be another one right there, and 4 degrees would be one right there. Okay, and so you can sort of get the idea that that slit's going to keep doing that, okay, in all these places we'll have a spot, okay, and just because of the tiny amount of degree change, but the fact that there's a lot more variance. And you can also understand that the wider the slits, the more capable you are of exposing lines that are from different, they don't all come off that same corner, so there's some variation, and that variation means that a beam that hit from here and a beam that hit the top of this edge, those 2 beams would be a different length, and so when you brought them together, they could add up to the same wavelength, the same distance in what quantities of one wavelength. So the key is the quantity of one wavelength thing. So anyway, the bottom line is that these dots for that pattern do go across the whole screen. So there is a dot place, a place where there's photons hitting, going across the whole screen. But the only ones you can see are the ones where this is making a contribution. So the only ones you see are the ones where there's a contribution from one of these edges, plus a contribution from here. I guess I could do that in white or something where the contributions are. So you can kind of get it, that it's the photon is visible when there's a contribution from both, or this, that, and this and that. You can see that these would have the right wavelength distances to make a photon visible there. But here, they'll be out of phase. Okay, these lengths, this length for this spot isn't going to be a wavelength difference from either here or here. So they're going to be out of phase. And so you won't be able to make the photon in those locations because they're still going to be out of phase. There's still energy hitting there. There's still bits of photon. But you can't make a photon because you're not getting enough bits, enough ingredients to make the photon. So, so I don't know if I have to go over the change the idea of what a photon is, but I've sort of pointed out a photon is quanta of energy at a specific frequency, that is a distance between them. They're all moving the speed of light in a ray form, and the alignment is a little bit off, and that's polarization. And so they can be, it's like the gun can move a little bit as it's shooting the bullets in a direction. And it's the same argument as the antenna argument. When the photon is created, it's created by electricity. Electricity moves a certain speed, and the speed the electricity moves through the atomic material is dictating how many bullets you can fire in that amount of distance, that amount of time. And that's basically what the polarization represents, is the atoms that are firing electrons at the right, moving electrons in a material based on a stimulus that you push through this way. So you push energy this way, and it fires the elements of the photon this way, so to speak. So the polarization is a representation of how many atoms you're involving, and the fact that the atoms are spread over a distance. The gun analogy is easy enough. You can only move the gun in one direction at a time, because that's the way the electricity is flowing, so to speak. So you can either polarize this way or you can polarize this way, but it's just how much out of alignment the gun is each time you fire the bullet. But anyway, so what's happening in this experiment is that the photons are being broken by hitting the surface. Like some of these hit the surface material, hit the substance, so they get knocked off, and then the ones that go through, different ones hit electrons. So some piece might go here, another piece might go way over here. So depending on what they hit, these little bits, as they go through, they're getting broken off and separated. So this bit goes there, this bit goes there, this bit goes over there, this bit goes straight. And the truth is, this is happening to each one of the photons. So eventually you're just putting together ones that all went straight, or ones that all went this direction, or ones that went this direction. And so you have to not only have the bits, that is, you have to have them in the right sequence, but you have to have them in the right phase. You can't have one here instead of here. So that's the mechanism that basically is saying that the photons are fundamentally destroyed going through the slit, and you're just recombining pieces of different photons at the location. And that's why this geometry works, because a bit from one photon, you got a bunch of photons going through, again, a bit from one, okay, combines with a bit from this one, and then a bit from this one, and a bit from this one, and those bits add up to a new photon. And essentially the same thing is happening here, is that they're just getting broken, and then you're just picking the spots where the phase geometry is correct, where all of these distances, this distance plus this distance, will equal whole wavelengths. So it'll put it back in phase. So even though the two photons might be in space in a different way, like they started off this way, this gun didn't fire until here, the fact is, when you re-alter them, they're going to reconstruct a photon. And the trick is that even the ones where the distances aren't the same, so this is something they don't tell you, so a photon that's a little bit out of phase here, okay, comes out of this one, and it's a different phase than a photon that's hitting this edge. So there's a photon coming through here that's out of phase with one coming through here. Well, the truth is that when the distance is the wrong distance, it'll reconstruct the photon, because you're fixing the phase. You're taking two photons that were out of phase, that is, like this. All right, so they're not in phase. And what you're basically doing is, because the path lengths are not in phase, and the photons were out of phase, you're basically reconstructing, putting the pieces back in phase. So now you can build a photon out of these pieces, because you've made them in phase, because you took two photons that were out of phase. That is, they left the starting point at a different time. And because of the shorter, one of them takes a shorter path length, and you're now able to reconstruct two photons that were out of phase, the pieces from two out of phase photons, into a photon. And so that's another reason why there's such variability in the size of this, is because of the fact that you're really able to take advantage of the fact that the path lengths aren't a what's the word for that? Aren't made out of a chunk of wavelength, and the distance difference between them isn't a full wavelength of distance. It's some lesser amount, and that fact enables two out-of-phase photons to create an in-phase photon. All right. Yeah, there's a lot to fiddle through, but the real point is that this pattern from these two outside slits, two outside surfaces, would realistically be invisible if it didn't get the contribution from the bits that are being deflected off the interior surfaces. So they're what's making all of those little things possible to see. You wouldn't see them if it wasn't for the contribution being created by the interior surfaces. So these interior surfaces are making the pattern being created by these exterior surfaces visible when it wouldn't be if it was, if you could have the same amount of light. Like I said, this is blocking the light here, and so this is less light here, and the pattern is so how to say it, it wouldn't be visible. So just, I can't say it any other way. So the trick of the double slit is that the interior slits are creating the zones where you make it possible to see these lines that are going all these places, and you're just not seeing these because there isn't enough photons, and you're seeing these because the extra bits that are being pushed out to those locations by the interior slits, the interior surfaces. But anyway, it's just a surface thing. So the first point to make is their math doesn't work. Their math doesn't explain the mechanics of this at all. They have no mechanical theory. They can't draw you any kind of diagram of their waves interfering that will explain the broken pattern. That'll explain this, the fact that there's dots inside this broken pattern. They have no explanation for that. Waves don't do that. And you can model it, understanding that these are real rays of photon. There's real little bits going to locations, and understand that there is no destructive interference. The photons are destroyed because the little bits bounce off different electrons, and the different electrons send them in different places by kind of strict rules based on how much pressure there is and how many electrons there are. There's more electrons the wider the slit, fewer electrons the narrower the slit. The fewer the electrons, the more pressure they're under. The more pressure they're under, the greater the angle of deflection. So with those simple rules, you can get the geometry that creates this pattern, but you can't do it with their theory. Anything else to say? So there's no waves, there's no destructive interference between the photons. The photons are destroyed by the objects and the electrons on the surface of the objects, and those surface electrons break the photons, scatter them, and all you do is recombine them. So all there really is constructive reconstruction. There is no destructive interference. There's destructive scatter and constructive reconstruction of not only the bits. You have to have the bits, and then you have to put the bits in the right phase. So the geometry is just about phase, and the fact is you can break out of phase photons to out of phase photons that wouldn't combine to make a photon. And you can make them make a photon by changing this geometry. Alright, this is probably enough. It needs to be more more exact. But anyway, I think you can get the drift that this certainly has hope of explaining it where they have no hope. And that's all I should have to be. That's all I should have to provide as evidence, is that this works theoretically. Theirs doesn't theoretically. It has no theory. They have no theory of an explanation. This provides one. Alright, so maybe we'll just leave it at that. And such. Yeah. Yeah, that's probably, I mean, you know, there's lots of details you can go into, but I think that's, you can get the gist of it.